Okay, these four problems are all kind of related because they involve complex numbers and either adding, multiplying, raising to a power, or dividing them. Number 10 asks me to take one complex number and subtract another one from it. Uh, pretty straightforward. The one thing that I've got to be careful of is the fact that this is subtraction, right? So I need to distribute this negative to both of these terms. I'm going to rewrite it as 5 minus 2i, and then I'm going to add a negative 4, and then I'm going to add plus 5i. So what I've done here is I've taken this negative 1 and I've distributed to both terms. So it's going to be a negative 4 plus 5i. Now, if I combine complex numbers, right, it's just a matter of gathering up the real parts and gathering up the imaginary parts. 5 minus 4 is 1, and negative 2i plus 5i is plus 3i. So that one's finished. Number 11, multiplication. We're going to multiply 2i, which is a purely imaginary number, times the complex number 2 minus 4i. When I do that, again, we're just going to distribute this and multiply by each one by it. I'm going to get, first of all, I'm going to get a 4i. And then from that, I'm going to get, and then next, I'm going to get negative 8i squared. Now, at this point, I might be thinking, hey, I'm done, but I've got to remember some of the things I know about I and when I square it. So, for example, remember, the definition of I is, is the square root of negative 1. If I square that, if I take I and square it, I actually get negative 1. Bizarre that you can square a number and get a negative number. Then if I multiply, if I raise it to the third power, right, I to the third, then this is going to be a negative 1 times another factor of I. So this is negative I. And then if I multiply it by one more I, right, I to the fourth power, that's equivalent to negative I squared. But because I squared is negative 1, that's negative 1 times negative 1. So this is back at positive 1. And then this pattern just keeps repeating, right? Anyways, over here, I just need to realize that, and this small part, so I'm going to write this as 4i minus 8 times negative 1, which totally transforms this, right? Now this is 4i plus the number 8. This question did ask you to write your answers in the form a plus bi, so I'm just going to translate this to 8 plus 4i. There we go. It's in that nice little complex number form, a plus bi, and that's what it is. Let's jump over to number 12. Number 12 has this 7 times 2 I to the 21st power. Now, the 2 is not being raised to the 21st power, right? It's only I that's being raised to the 21st power because of order of operation. But I do have this 7 times 2. So I've got this 14 out in front, and then I'm multiplying it by I to the 21st. So let's come over here and consider what that is, right? I to the 21st power. In the previous problem, I was just talking about how much I like I to the 4th a lot, right? If you look at these, I to the 4th is cool because it equals 1, and I can really handle multiplying by 1s a lot. So what I'm going to do is I'm going to rewrite this using this fact, right? I'm going to rewrite this as I to the 4th power raised to the 5th power. Now, I know you're saying, Mr. Roberts, that's only 20 factors of I, right? And it is. There's only 20 of them there. So I need to put one more additional I there. So that equals 21 factors of I. These are exactly equivalent to each other, right? I to the 21st is I to the 4th raised to the 5th times another factor of I. Again, the reason why I love I to the 4th is it's equal to 1. So what do I have here? I have 1 raised to the 5th power. You're kidding me. 1 to the 5th power is just plain old 1. And 1 times I is just plain old I. So this whole thing, I to the 21st power, is nothing more than I. So my answer is 14I. Last question I have over here, number 13, last in this little set. I'm dividing a complex number by a complex number. And, for the exact same reason I don't like radicals hanging out in the denominator, when we've got complex numbers, we like to rewrite them so that we do not have complex numbers in the denominator. So I'm going to kill the imaginary number part of the denominator by multiplying by the complex conjugate. Now, I can't just do that with just the denominator only. So I have to multiply both the numerator and denominator by this. But this value, right, if I multiply it by 2 minus 3i, experience has shown that that will not have any imaginary numbers at all in the denominator when I'm done. So if I take a look at this, what I've got here is I'm multiplying my number times the number 1. I'm multiplying this quotient times 1, so I'm not changing a thing. So let's look at each part of this, right? If I multiply denominator times denominator, I'm going to get 4, and then I'm going to get a minus, whoops, 4, and then I'm going to get a minus 6i, and then my inside product will be a plus 6i, and then finally I'm going to have a minus 9i squared. And it'll all clean up very nicely. Let's do the same thing with the numerator since we're here. My first product is going to be a 2, and then my inside product will be or outside product will be a negative 3i, and then inside I'm going to have a plus 4i, and then my last part there will be a negative 6i. All right, so let's clean up the numerators and denominators here. So we're just going to go down another level. And this numerator cleans up when I combine all of the i's that I'm seeing here. I've got, silly me. When I multiply I times I get I squared. This is bad, Mr. Roberts. It's too late. You shouldn't be doing YouTube videos this late at night. Do it in the morning once you got your fresh cup of coffee. Anyways, that numerator is 2 minus 3i plus 4i, and then minus 6i squared. Okay, good. So in my numerator, I've got a 2, and then I have a negative 3i plus 4i is plus 1i. And then I've got this minus 6i squared. Well, I know that I squared equals negative 1. So that's negative 6 times negative 1, which makes it plus 6. So that numerator is equivalent to 8 plus I. Denominator now, let's take a look at the denominator. I've got the 4, right? There it is. And then minus 6i plus 6i, those cancel. So I'm going to have a minus 9 times I squared again. I squared is negative 1. I guess I'll just write it this time. Okay, we're close, right? Well, one more step here. I'm going to take this thing now, and I think for the final time, this numerator 2 plus 6 is going to be 8. 8 plus I. And my denominator, I've got a 4 minus 9 times negative 1, which is 4 plus 9, or 13. So this right here, beautiful. I'm done with it. There's no complex number in my denominator. And this is, as the instructions, I've simplified this very nicely.